Okay, back to the talks of today. So I would like to introduce Professor Antônio Geraldo Ferreira. He will give our next talk. The talk is about synergy between GNSS and remote sensing products. Professor Antônio Geraldo Ferreira is graduated and licensed in physics from Gnss, and he has his specialization in the satellites for the National and Oceanic Atmospheric Administration in Washington, USA, 1997, and his master in science, marine science and tropical marine science. And he's currently a professor of the Institute of Sciences, of Sea Science and Ocean Science, I think it's from Federal University of Ceará. So he's a professor here in our institution. His PhD in physics from the Department of Physics. So I can speak in Spanish because Departamento de Física de la Tierra y Termodinámica de la Universidad de Valencia, España. So yeah, has also some lots of experience in Spain. And yeah, he works with climatology for satellites using artificial intelligence, also in synergy with data sensors from the geostationary Earth radiation budget, and which is now used in the Meteosat satellite, starting the energy balancing in the surface. So that's it. So thanks, Geraldo, and yeah. Okay.
Good morning, everybody. First of all, thank you very much for inviting me to make this presentation. At Labomar, I am the coordinator of the L08. L08 is the Earth Observation Labomar Laboratory. The main activity of this laboratory is to develop biogeophysical products based on remote sense, as well education purpose. I will show you some products that we developed there and some education activities that you developed there too. Here you can see the global satellite observing system. The products that we developed there, we use main satellite of this system, because here we have geostationary satellite like Meteosat, Gnss from USA, and another orbit that this satellite are polar orbit satellite like NOAA, METOP, Sentinel. I am showing you this figure because the students normally are trying to develop her graduation works using data from this satellite. Normally the portion of the electromagnetic spectrum that we use to develop products based on satellite are from ultraviolet, visible, infrared, and microwave. Normally, these three parts of the electromagnetic spectrum are used to develop the products that I will show you in the next figure. Here are some biogeophysical products generated by using remote sensing images. The first of all is sea surface temperature. This product was developed by using METOP-B satellite that has on board AVHR3 sensor. This parameter is very, very important for our region because the SST is the main input parameter that we used to make climate prediction in our region. Here we can see from January to December the warm water displacement during the year. The ITCZ in meteorology, we say that the ITCZ, that is Intertropical Convergence Zone, likes very much warm water. And normally the ITCZ, the rain season in our regions, a semi-arid region, is between February to May. We can see here in this year, the warm water is located here over our region. And in this year, in this period of the year, the February to May, ITCZ is located here. If the atmospheric and the ocean conditions are good, we have a good season here in Northeast Brazilian region. Another product is ocean color. Here is a climatology. These pictures were generated by using 10 years of data, using MODES satellite, aqua satellite, that has on board the MODES sensor. And here we can see during the period December, January, February until November to December. And here we can see the chlorophyll concentration in milligrams per cubic meter. And here in blue, in violet, are located that we call desert oceans. Here, the chlorophyll concentration are very, very low. And here we can see some oceanographic aspects. Here we have, if you look for number 2, we have this Atlantic Sul current. And here the counter north current here, counter current north of Brazil. And here we have the discharge of Amazon River in the ocean. And here in the west part of the continent, here in Africa coast, and here South American coast, we can see that the chlorophyll concentration are high than other areas in the ocean. And this information is important for the fishermen, mainly in Peru region, and here também too. Probably this chlorophyll, high chlorophyll concentration here is due to the Bengal current acting here in this region. And in order to analyze this part of the image related to discharge the river Amazon in the ocean, we needed to be careful in classify these aspects with chlorophyll, because here are very, very sediments that can turn complicated to define if this radiance is from the chlorophyll A or from the sediments. by using METOP-B data too. In this time, we are using IASI. IASI is a sensor on board METOP-B. And here we are comparing the temperature profile estimation with sound made on board this ship, a Brazilian marine ship called Vital de Oliveira. This ship normally is used to make the maintenance of the Pirata array in the Atlantic. In the Atlantic Ocean, we have about 20 fixed buoys, and every year we need to make maintenance of this buoy. The Pirata project is an international project in collaboration with USA, French, and Brazil. And and here we can see a profile, radiosonic profile in green color, and IASI sensor, the profile retrieved by IASI sensor. Here we have a comparison of the two measurements, and we can see that these two types of measurements are very close. We have a high correlation between profile estimated by IASI with the radio sound. This type of products have been generated by the first time from a ship. I mean, by the first time we compare data from radio sound launched by a ship with satellite IASI sensor. We are testing two IASI profiles in the region of Fernando Noronha. Fernando Noronha is an island in Atlantic Ocean, and we have a radio sound station there, and we get some profiles made by radio sound launched from there to compare IASI. And again, we can see a high correlation between the profile estimates by radio sonda and that estimated by or retrieved by IASI. Another product that you are generated by a student that works with me in the lab, was using orbital carbon observatory OCU2 to compare CO2 measurements made by ships. The ships normally make this road between Africa and South America. Over the Atlantic, we get the data from the ship, and we compare data from this lighthouse station, 3 lighthouse stations. One of them located in Natal city in Brazil, another in the center of the Atlantic, another in Gobabeb station in Namibia, Africa. We use these in situ measurements to compare with the data retrieved by OCU2. Here we have a photo showing the Gobabeb station in Namibia, and one example of the time series between measurements based in situ measurements made by Gobabet Station, and that estimated by OCU2. Here we have a good correlation between these two measurements. And here we made a linear correlation, and we can see a good correlation between these two data. Another purpose of the OLAB is scientific education purpose. In order to reach this objective, we generate that we call the image of the week. The idea is to turn available for the people, scientific and the public in general, information about satellite, and in a way, form to call the attention for the application that we can do using satellite data. And here, for example, we are calling attention for the cyber satellite, a Brazilian and China Brazilian satellite, showing the detailed over this region, Limoeiro do Norte. Limoeiro do Norte is a city in Ceará state, showing this area where we have crops, and you can see in green color areas that are preparing for crops, and another that still are preparing for crops. And together this information, we normally try to write a easy test for the people, and we put together some information concerning the satellite to turn this information useful for the user. Here we have another example showing the Açude Pentecost in Ceará state, and together we put some information about the reservoir that is here, and together with this information, again, we put some information about this satellite, because the idea is turn more easy for the people, know information about the characteristics of the satellite that we are using to generate this product. Here, sometimes we turn available the image of the week in English too, sometimes in Portuguese, depending on the public that we are trying to reach. Okay? But when we make the product in English, we turn available this image of the week in Portuguese too. And here we make a description that you are viewing in this picture, and we try to put some information or some characteristics about the satellite, as I said, to use to generate this picture. Here is another image of the week. In this case, we are using them to not only METOP satellite, but we are using Meteosat satellite too, because here we are in February 22, and the ITCZ in this period was very, very active. And you can see here by using Meteosat image, you can see here the ITCZ, and this with the cloud, the convective cloud associated in that period in February, March. In February, March, we have a lot of rain due to the ITCZ acting over our region. Sometimes when we see some news in the press and you analyze that it's possible to get that news and using satellite to put for the public this information using satellite. Here we have an example in February 26, 2021. We have a flood in river, Juruá River, and use Sentinel image, Sentinel 1A and 1B. And here we can see the river in black color. And here a photo showing the flood impacting in this area, in the population of this area. And here again, we generated the image and put all the characterization, I mean the satellite, the sensor characteristics that was used to generate this kind of image. And here we have using normally two kinds of polarization. Another interesting product that you generated is soil moisture. Soil moisture is important information for the climate prediction over our region. This kind of information, the idea is to use this kind of information as input in the climate model. This information is generated from a small satellite. A small satellite was the first satellite that generates soil moisture and the ocean salinity for the first time in the world. And this product will take part of the drought monitor that Eduardo Sávio talk or mentioned in the previous talk. And the idea, actually we are generating this information over Northeast Brazilian region, but the idea is generate this product for the whole of Brazil. Here we have a Brazilian, the soil moisture generated using ascendant orbit, and here descendant orbit. And here we have a zoom, we have the Northeast Brazilian region, a semi-arid region. Another product that we use to generate the image of the week is the ocean color. The chlorophyll concentration over reservoirs in semi-arid region. And here we can see the blue color through red color, where red color means more chlorophyll concentration in the reservoirs. When the Amazonian satellite, Brazilian satellite was launched, we turned available this information about the satellite. We made a description, a easy description about the satellite characteristics, and the first images generated by the satellite. In this way, the idea was turn this information available for the general public, because this satellite was made entirely in Brazil. It's a Brazilian satellite. Here, as you know, we have in this ship in Canal de Suez, and we get we get this information from the players. Here we have an image from the Pleiad satellite showing the canal, the Suez Channel, and the ship here. And here, using Sentinel 1B and 1A, we can see the ships waiting to cross the channel when this ship was removed from here. And you use it to the satellite information to desire a Merry Christmas for the peoples. And we have always have opportunity to teaching things about remote sense. We try to do. And here we have located the Santa Claus city. And here some photos sent by me for a student that worked with me before. And here we send a discharge for many people. And actually, this image weeks are available for the people that are in the WhatsApp group that we have, and some we generated this image of the weeks in PNG format. It's more easy to see in the WhatsApp, and some people are scripted in the email. But the idea is to put this information in the website that you are building at this moment. I think that at the end of October, we will have the lab website online, and we turn available these products and the image of the week in the website of the lab. I am not a specialist in working with Gnss and remote sensing products, but I look for some papers that do it. The product that we can use GNSS data in remote sensing is the soil moisture. Here, first of all, we make the download of osmosis data, and using a Python, we convert in a adequate projection, because the osmosis image is a different format, and we needed to make some reprojection of the image. And after that, you use the GeoTIFF images in QGIS to generate the soil moisture. And here we have this product for northeastern Brazilian region. And here in the right, these two figures are soil moisture, and this picture is TVDI, temperature vegetation dryness index. And you use it to compare these two products. Here you can see 0 means that you have a good humidity in the soil, and 1 means drought area. And here in the color scale, blue, dark color means more soil moisture. In 2015, we have in Ceará a drought year. In 2017, too, we have a drought year. And for the first time, after 5 or 6 years of drought, we have a good rain season in our region. You can see if you compare the other years, here we have more soil moisture in this region because it's a response of the rainfall followed in this region in this period. Here we have some papers. I give you in this presentation the paper reference. Here we have an example of Gnss and a passive radiometry and the osmosis data. Here in a vineyard in Valencia, we have a plateau with vineyard here, and we have here installed this tower. In this tower, we have L08 2L band. It's a radiometer. This radiometer was used to validate the osmosis data, soil moisture osmosis data, since 2010. And recently, together, the L08 sensor was installed the Gnss antenna. And here we have the up-look antenna. We have received the Gnss signal, and from this part of the sensor, we receive data from the soil. And after that, these data are compared with soil moisture. Soil moisture in situ measurements are made by using soil moisture tetaprobe sensor. And after that, we can compare the results made by all the sensor in the comparing with precipitation data. You can see when we have precipitation events, the soil moisture responds to this event. And here we can see the ocean pole. Ocean pole is this equipment, a GPS equipment used, and you can see that there are good correlation between in situ measurements and the ocean pole L08 measurements. And here you can see too the ocean pole measurements perform better than that L08 measurements. Here we have another reference about using GNSS and the remote sensing data. This paper describes the altimetry made in the ocean and in the reservoirs. Here is another GNSS equipment sensor, CY GNSS data. It was a NASA sensor cyclone global navigation satellite CIS mission. This mission was launched in 2016. Here we have the products from New Space. This period was launched a small satellite constellation to make measurements from the ocean surface wind speed wind speed in the hurricanes. Here we have another comparison between GNSS data with satellite data. And here we have the GPS data, the Gnss satellite data, and the hydrological station in different parts of the Amazon basin, showing the good agreement between these three types of measurements. Okay. Now I would like to talk to you about the Space Week Nordeste 2023 that you are organizing together NASA and the Brazilian Space Agency. Here we have the website. You can look for this website. The tentative schedule is here. The Space Week will begin in August 14 until Sunday 20. And the idea is to have a mini course and the keynote speakers acting during the event, discussing about space technology for the benefit of nature and society. And the idea too is to have a round table with specialists to talk about the Earth observation and the associated technology for sustainable development goals. The mini course confirmed until this moment are about ocean remote sensing by using SAR images, Earth machine learning applied to satellite images over ocean and over land, introduction to nanosatellites and CubeSats, introduction to science and the model rocket, and this mini course is addressed mainly for teachers, and we'll talk about innovation in science and education. During the Space Week, we will open for abstract submission. Until this moment, we are putting 6 STEM related Earth observation in support of sustainable development goals, space-based weather and climate extreme events. New space, we are in the new space era, and we have talks about new space, disruptive space technologies and innovations, the deep space missions, and the air and aerospace economy in the continental water cycle from space, the SWOT mission. This week, we are having a field campaign here in Ceará, and we are installing some equipment in order to make the validation that what satellite that will be launched in November of this year. Thank you very much.
Okay, so thank you, Geraldo, for the nice talk. Yeah, many things we are doing in this area. Do you have any question here or any from the audience? Assim. You have?
Oh, thank you very much for the nice talk. My question is, when you try to combine the remote sensing with GNSS. So it means that you are using data from geosynchronous orbit and LEO satellites. So these are the two main sources from where you can analyze the data.
As I said, I'm not specialist in combining GNSS and the remote sensing data. But in Valencia, when you use the GNSS data, use the geostationary satellite to get the data, compare with the Albará, because we are using geostationary satellite and the ESMOS. ESMOS is a polar orbit satellite. And we combined these two information from Albará, information from GNSS to compare the data with in situ measurements, and after that with the measurement made by estimated by satellite, soil moisture estimated by satellite, because Albará was the sensor used to validate using the field campaign in that period, 2009, when ESMOS was launched. We compare data from, we have a Albará sensor displayed in various sites around the world, and is one case that you use to validate the data.
Do you have any analysis on the agriculture?
Yes, yes.
Okay.
Because there is a vineyard area. But it's possible to, I think, to use this data to validate over the water bodies too. Because one paper that I put in the presentation, the researcher show an application by using this technology, the GNS technology, to study the water surface.
Okay, thanks.
Okay, assim, any other questions? I have just one quick question about the GNSS-R reflectometry, right? Do you have access to the stations here in the state of Ceará? I mean, or do you receive this data from a third party, or do you really measure by yourself when?
Okay. We have this sensor at that area because when ESMOS was launched, that area was classified at validation area, and this satellite group from the University of Valencia made an agreement with ESA, and ESA sent this equipment directly to there. But we have access to the data, but we have this equipment here. I don't know if there are another kind of equipment in other sites in Europe, but in Valencia, we have this equipment there because it is an onshore station for validation.
And how long is this equipment working there? It's for a long time in Valencia. I mean,
I think for about 4 years.
4 years already.
Yes, make continuous measurement. Yes, they made a lot of experiments using this data. Not using only GNSSR, but Albará, another kind of instruments are put in the soil in order to estimate the soil moisture.
Okay, thanks, Geraldo. So, yeah, I think we don't have questions in the chat, no? No? Okay. Okay, that's it. So let's thank again Geraldo for the talk.